The topic for this lesson is the power and sum difference rule of derivative. In this section, we will focus on some derivative rule that will let us find formula for derivative when our function comes to us as a formula. Using the rules will be much easier than using the limit definition of the derivative that was introduced in the last section. So by the end of this lesson, you'll be able to differentiate using power rule or the sum difference rule. You will be able to find the derivative of a constant or a constant time of function, determine points at which a tangent line has a specified slope. So remember, the derivative represents the slope of the tangent line. Just keep that in mind. So the notation we use for derivative is f prime of x or dy over dx or d over dx of f of x or d sub x of f of x. So this dy over dx, this symbol, this notation is referred to as Leibniz notation. And if you are curious to know who invented calculus, I suggest you watch this YouTube video, which is about 5 minutes. It's really interesting video. Just watch that just for fun, okay? So here are 4 rules, derivative rules that we'll be using. And these are the simplest rule for basic functions. We will not prove these rules here, we just use them. Okay, so rule number 1 is constant rule. So the derivative d over dx of k is 0, where k is a constant. Power rule. So we have a function x power n. The derivative of x power n is d over dx is given by nx n minus 1. nx raised to power n minus 1. Another rule is multiplication by a constant. If we want to find the derivative of a function which is multiplied by some constant k, then the derivative will be that constant times the derivative of the function f prime of x. So if we are given sum of two functions, let's say f of x and g of x, then the derivative of this f of x plus or minus g of x will be f prime of x plus or minus g prime of x. So let's look at some of the examples, whether that makes sense. Here, find the derivative of f of x equals 5. Clearly, this is constant. So from the rule, constant rule, we know that derivative of constant is 0. But what does that mean? Let's look at the graphical meaning of this, okay? So f of x equals 5 or y equals 5 is actually a linear equation, and whose graph will be a straight line, horizontal line. We know that the tangent for this line is by itself. So we know that the slope of a horizontal line is 0. Therefore, derivative of this is slope of is 0, slope of the tangent line is 0, so it makes sense. Derivative of constant is 0. Let's look at another example. This is also very familiar equations for you. So find the derivative of y equals mx plus b. If I draw the graph of this function, depending on the slope of m, this is clearly a linear equation, okay? And tangent for the linear equation is by itself. So the slope of the tangent line is dy prime, or you can write dy over dx. Okay, we can also write y prime to represent the derivative, or dy over dx must be m, because the slope of this, the tangent line for this linear equation is by itself, And we know that the slope of this linear equation is m, therefore the derivative must be m. Now let us use our formula. Does that make sense? So using the formula, so dy over dx is d over dx of mx plus b. Okay, so that means I can write this using this sum and difference rule. I can write d over dx mx plus d over dx b. So we know that this power is 1 and this constant time of function. So that means we will get derivative of the first part is constant is m, because m is a slope, it's a constant m, and then the derivative of that using the power rule. Okay, power rule is nx n minus 1. So let us use that. N is 1 times x power n minus 1 and plus derivative of this b. B is constant, so derivative will be 0. So that is 0. So this gives me m and x power 0, which means m. Okay, so, and it makes sense. Now, let us look at few examples just for fun. Okay, y equals x raised to power 100. So the solution will be dy over dx is using the power rule 100. You see the power rule is nx raised to power n minus 1. Nx n minus 1. So that is 100 x raised to power 99. That should be the derivative of these functions. In the same way, let us look at this. First of all, when you are given the radical sign or if the function is in the denominator, I suggest you change it into some power, okay? Some power form. So for example, in this case, you change it into x power half. Now your derivative is using the power rule n, which is half, x power n minus 1. So that's going to give me half x. Half minus 1 is actually negative half. So you can write this as half. This power is negative. You may want to bring it down. Recall from your high school algebra when the power is negative, and if you bring that at the bottom, so that will be positive x power half, which means square root x. So what we got here is 1 over 2 root x. Okay, 1 over 2 root x. In the same way, let's look at this. So here we have a constant time x power. Constant is 7 times x power 4. So the derivative will be 7 and the derivative of this x power 4 using that constant time function rule. So we're gonna get 7 times 4x raised to power 4 minus 1, which gives me 7 times 4. You can write 7 times 4 is 28, x raised to power 3. All right, so from now onwards, as we have seen that there is 7 and 4, ultimately we have to multiply this power with the coefficient. So from the rest of the problem, maybe we'll go directly, like derivative of this will be 4 times 7 is 28, 7x power 4. So you can directly find the derivative. 7 times 4 is 28, x raised to power 4 minus 1, which will be 3. So that's fine. You can do it directly. So let's look at another example. Find the derivative of f of x equals 5x raised to power 7 minus 4x raised to power 5 plus 0.5x squared minus 10x plus 157. So derivative is d over dx, or you can write, if you like, you can write d over dx of f of x or f prime of x, doesn't matter. So this will be 5x power 7 minus 4x power 5 plus 0.5x squared minus 10x plus 157. So this can be written as f prime of x. And so you will get here d over dx of 5x power 7 minus d over dx of 4x power 5 plus d over dx of 0.5x squared minus d over dx of 10x plus d over dx of 157. So using the power rule and the constant times function rule, you're going to get 7 times 5 is 35x power 6, x raised to power 6 minus this will be 5 times 4 is 20, x raised to power 4 plus this will be 1, x raised to power 2 minus 1 is x power 1 minus this will be, as you know, that this will be 10 times 1 is 10, x power 0 plus derivative of constant is 0. So your final answer is, because x raised to power 0 is 1, and that will be your derivative. Now, you don't have to do all these steps. You don't have to solve every steps. You can actually find the derivative directly. Okay, let's look at example 5. So we are given a function 4x cubed plus 2x squared minus 25x plus 1. So the derivative will be f prime of x equals 4x cubed plus 2x squared minus 25x plus 1. So you can actually use the rule directly. This will be 4 times 3 is 12x squared plus 2 times 2 is 4x raised to power 1, because 2 minus 1 minus 25 times 1 is 25x power 0, and derivative of 1 is 0. So that's going to give me 12x squared plus 4x minus 25. And we need to evaluate this at when x is 2. So when x is 2, when x equals 2, so f prime of 2 is going to be 12 2 squared plus 4 times 2 minus 25. And this becomes 31. Okay, so let's look at another example. Find this time with radical sign. Like I said earlier, you need to rewrite this, okay? Rewriting the function will get f of x equals x, this third power, 1/3 power, x raised to power 1 over 3 plus this will be 6x, this is x power 7, fifth root of x power 7 is actually x power 7 over 5, but because this is in the denominator, bringing it to the numerator, the sign will change. That will be negative 7 over 5. And so your derivative f prime of x is going to be, again using the power rule, 1 over 3 x power 1/3 minus 1 plus 6 times negative 7 over 5 x raised to power negative 7 over 5 minus 1. So simplifying this, you will get 1 over 3 x raised to power 2 over 3 and minus 42 over 5 x raised to power negative 12 over 5. So this looks a little ugly. So let us write it in a nice way. You can leave this like this, but if there is a negative sign, I suggest you can change it into, making it positive, bringing it down. But, that's the derivative. Let's do a little algebra. By the way, this is negative 2 over 3. So if you bring it down, it will be okay, x raised to power negative 2 over 3 becomes this, minus 42 over 5. And if you bring this down in the denominator, that becomes fifth root of x raised to power 12. That should be your final answer. Okay, now let's look at example 7. Consider the function f of x, which is negative x cubed plus 6x squared. In part A, we want to find the points on the graph of f at which the tangent line is horizontal. In part B, we need to find x values on the graph of f at which the tangent line has slope 6. So let's work part A first. So find the point on the graph of f at which the tangent line is horizontal. What does that mean? Tangent line is horizontal. That means the slope of the tangent line is 0. Okay, so tangent line is horizontal. This implies slope of tangent equals 0. So this implies derivative is 0. All right. So let us find the derivative. We are given the function, since f of x is given to be negative x cubed plus 6x squared, its derivative is negative 3x squared plus 6 times 2 is 12x. So this derivative is 0. That means negative 3x squared plus 12x equals 0. And now solving this, you can take negative 3x common, factor out negative 3x, x minus 4. So negative 3x equals 0 or x minus 4 equals 0. So this gives me x equals 0 or x equals 4. Now it says that find the points. That means we need to find the coordinate x and y. So our goal is to find when x is 0, when x equals 0, your y value, which is actually the function f of 0, is going to be negative 0 cubed plus 6 times 0 squared, which is 0. So the first point is 0 and 0. And the second point, when x equals 4, y equals f of 4, which is you will get negative 4 cubed plus 6 times 4 squared. That's going to give you 32. So another point is 4 and 32. Okay, these are the 2 points where the tangent line will be horizontal. And let's see whether that makes sense or not. So we have this f of x equals negative x cubed plus 6x squared, and I have the graph of that function. Okay, this is my function f of x equals negative x cubed plus 6x squared. And as you can see, if I draw the graph right at 0, 0, okay, at this point, if I draw the graph, if I draw the tangent line, that tangent line will be horizontal here. And also we have seen that the tangent line is horizontal at 4 and 32. As you can see, 4 and 32 is this point, and if I draw the line there, tangent line, then that tangent line will be horizontal. Okay, so we have just seen from the graph that when we draw, if we draw the tangent line at 0, 0, which is this point, and it is horizontal, and the tangent line here is horizontal. Now let's look at part B. In part B, we want to find x values on the graph of f at which the tangent line has slope 6. So what that means is, at this time, the tangent line has slope 6. Tangent has slope of the tangent has slope 6. That means, this means the derivative is 6. All right, so the derivative is 6. So that means you have negative derivative we already calculated, which is negative 3x squared plus 12x equals 6. Now this is negative 3x squared plus 12x minus 6 equals 0. And factoring out 3, you're going to get x squared, negative 3, you will get x squared minus 4x plus 2 equals 0. So which means x squared minus 4x plus 2 equals 0. Now solving this quadratic equation, this is not easily factorable, but you can use the quadratic formula. So the quadratic formula is if you have ax squared plus bx plus c equal to 0, and the root or the x value for this will be negative b plus minus square root b squared minus 4ac over 2a. So we know this formula from high school, so we're going to use that here. So that gives me x equals negative b plus minus square root b squared. So negative 4 squared minus 4ac over 2 times a. And if you simplify this, you will get this is 4 plus minus square root 8 divided by 2. So the x value will be, one is 2 plus square root 2, and another is 2 minus square root 2. Okay, so the questions ask us to find the x coordinate only, then we don't worry about y, but if we want to find the y coordinate, then yes, of course, we can find it by substituting that value in the original equation function. Okay, now the application part. The question is, how can we apply this concept in different field, in real world situations, okay? Derivatives are useful in analyzing changes in cost, revenue, and profit. The concept of a marginal function is common in the field of business and economics. And what it means is it just implies the derivative. So marginal refers to the rate of change. And so if we want to find the marginal revenue, marginal profit, marginal cost, we just find the derivative of those functions, okay? Example 8. The cost of producing X item is, let's given C of X is square root X $100. Part A, what is the cost for producing 100 items? 101 items. What is the cost of 100 first item? Let us calculate this. And to calculate this, we don't need any derivative here. We just need to find the total cost producing 100 items. So we are given the function. We have C of X is square root X. So you can find C of 100 equals square root 100, which is 10. The unit is in $100, $100. And C of 101 equals square root 101, which gives us approximately 10.049875 $100. And now what is the cost of 100 first item? So basically we subtract that, okay? Cost of producing 100 first item is given by unit is $100. $100. If you want to change that into dollar, so you're gonna get, if you just multiply that by 100, you're gonna get 4.9875. I would go $4.99. That is the cost producing 101th item. Okay, part B. For CFX square root X, calculate the marginal cost, which is C prime of X derivative, and evaluate it at X equals 100. So first let us calculate, okay, we are given C of X equals square root X, which is X power half. And if you calculate the derivative of that, you're gonna get half X power negative half, which is 1/2 square root X. So marginal cost at the production level 100, X equals 100 is 1/2 square root 100. And that's going to give me 1/20, which is $0.05 $100. Because the unit in dollar, if you change that into dollar amount, you're going to get $5. Okay. Now, how does your answer compare with the last answer in part A? Look how close they are. So this one here, in part A, our answer is $4.99, and here we got $5. How close they are, right? So this proves that The derivative, which is the instantaneous rate of change at a point, approximate an average change at that point. Okay, so if we keep the x value close together, so in terms of the derivative of the cost function, as stated above, the marginal cost approximate the cost of producing one more item. For example, in this case, 100 to 101th item. So the derivative will actually approximate that value. And the last question here for this section, example 9. Suppose that the total cost in hundred of dollar to produce X thousand barrel of a beverage is given by C of X equals 4x squared plus 100x plus 500. Find and interpret C prime of 5. So we want to find the derivative, which is C prime of X is 8x plus 100, and C prime of 5 equals 8 times 5 plus 100, and that's gonna give you 140. So what does that mean? This means okay, notice that we got the C prime of 5 is 140, and this is given in also the unit is $100. So this means after 5,000, because this one is X is given, the unit for X is 1,000. So it means after 5,000 barrels of the beverage have been produced, the cost to produce 1,000 more barrel will be approximately $140, $100, or $14,000. Okay, so this represents the marginal cost. Marginal cost means at the production level 5, the change in cost, one more 1,000 barrel to manufacture, to produce, the cost will be $14,000.